Today we're going to be talking about spheres in space. So what I mean by that is we're going to have a coordinate space, and we're going to be talking about what happens when we have a sphere. So the way that I draw something so that it actually looks like a sphere is that if I have a sphere, what does it look like in terms of an equation? And how can we take the equation and figure out things about it? The main thing that a sphere has is a center and a radius. And just like a circle, it's all the points at the same distance from the center. It's just now all the points are the same distance from the center in 3 dimensions, so there are more points than a circle has. So recall that the equation of a circle in 2-dimensional space is x minus x1 squared plus y minus y1 squared equals r squared, where the center is x1 comma y1 and the radius is r. We got this from Pythagorean theorem between whatever the center is and the point that we're trying to reach on the circle. And the exact same idea will work because we just talked about the 3-dimensional distance. In a sphere, we have the same formula, except we have plus z minus z1 squared. So x minus x1 squared plus y minus y1 squared plus z minus z1 squared equals r squared. Make sure that you get this in your notes. The center should be x1 comma y1 comma z1, and the radius should be r. As always, note the negatives in the formula. So if we see x plus 3 squared, then that's going to be an x coordinate of negative 3, etc. So, write the equation of a sphere with radius 9 centered at this point. So the formula is x minus x1 squared plus y minus y1 squared plus z minus z1 squared equals r squared. Well, x1 is 3, y1 is 8, z1 is negative 4, so minus negative 4 becomes plus 4, and 9 is r, so that becomes 81. That is the equation of the sphere. It is possible that in some cases you might be asked to write it where everything's on the left side of the equation and you've already multiplied this out. Remember that if you want to multiply this out, you have x minus 3 times x minus 3 gives you x squared minus 6x plus 9. It's not x squared plus 9. What is the radius of the sphere indicated below? It is tempting to say that the answer is 2, because typically we look at this right side and say, oh, it's the square root of this. But it's not in standard form yet, so we can't do so. Specifically, we need to write it so that it looks like this, where we have x minus x1 squared, y minus y1 squared, z minus z1 squared. So let us identify, okay, here's our x coordinates, here's our y coordinates, here's our z coordinates, and we need to get those to look as squares. So the way that we do that is completing the square. If you've forgotten how to complete the square, go back, find some videos on completing the square. But the basic idea is that we're taking half of the b term and squaring it and adding it to both sides. So for the x, we're taking half of 4 is 2, squaring that is 4, so we're adding that to both sides. For this, we're taking half of negative 18 is negative 9, squaring that gives us 81. So I'm adding 81 to both sides. For blue, I'm taking half of 12 is 6, squaring that is 36, adding that to both sides. And that will give me 3 perfect square trinomials. X squared plus 4x plus 4 plus y squared minus 18y plus 81 plus z squared plus 12z plus 36 equals 4 plus 4 plus 81 plus 36, which I believe is 125. Now, we can write it in standard form. X plus 2 squared plus y minus 9 squared plus z plus 6 squared equals square root of 125 would be 5 square roots of 5. And now we can say, oh, wait, this should still be 125. But the radius is 5 square roots of 5. So that's the radius. The answer to the question that they did not ask is what is the center of this circle. Negative 2, comma 9, comma negative 6 would be the center of this sphere. Because we have 3 dimensions, we have to call it a sphere. All right, thank you.